All right, so this is the screencast for chemical reactions objective number 4. We're going to describe how to write net ionic equations. So this is one of those equation types that we talked about in objective number 1, and we're going to discuss the essential question is how do net ionic equations differ from balanced chemical equations? So a net ionic equation, when you think of net, you need to think of like a final product, or what's going to be, the stuff that reacts in the final ending reaction. So ionic equations show the individual ions in a reaction. Solutions or aqueous means that they've dissolved in water. So the state is going to be labeled as AQ. That means they dissociate, meaning they break apart. So like sodium chloride would break apart into sodium 1 plus chlorine 1 minus. And that's what we mean by ionic equations are going to show the individual ions. Ionic equations can't be written for molecular compounds like combustion reactions because things are not going to be dissolved in an aqueous state. So there's only a handful of equations you can really do this with, which is why they're specifically the ionic equations. The most common solvent or dissolver is water, but there are things that dissolve in like ethyl alcohol or vinegar or oils that don't dissolve in water. So we're going to have to use our solubility chart here to determine the state for each of the compounds. So soluble, no reaction, you're going to see aqueous, or if something is soluble, you're going to see it as an aqueous solution. If something is in that double displacement reaction of a no reaction, you're going to see it listed as a solid, meaning it forms a precipitate. And so if you get that precipitate on the product side, then you have a reaction. If you have the precipitate on the reactant side, or if you have the solid on the reactant side, that means it doesn't dissolve in the solution and you're probably not going to get a reaction. So our solubility chart is going to help us to determine if things stay aqueous or if things form solids. And as we do some practice with this, you'll see very quickly that you can figure it out easily. So spectator ions, these are the things that don't react but are present. So they're going to be present in the aqueous solution, but they're actually not what's reacting. And so when you see a solid forming on the product side, the solid that forms between those two elements, or the element and the polyatomic ion, those are the only things that are really reacting. The other things are staying dissolved in the water. And so we call them spectator ions. There's two types. There's complete ionic, which shows all the ions present, and then there's net ionic, which show only the ions that are reacting. So you've removed the spectator ions. So that's what we mean by net ionic equations. So you have to write a complete ionic equation, then you write the net ionic equation. So the steps for writing it, you're going to want to start with a balanced equation. You're going to want to use the solubility chart to determine the states of matter in water. So determine if they are aqueous, so if they do dissolve, or if they stay a solid. So you're going to write the complete ionic equation then. And you're going to break up the aqueous compounds into their individual ions. And from there, you can remove the ones that don't react. So if something stays the same on both sides, meaning it stays dissolved on both sides, that's a spectator ion. It's not reacting. If something forms a solid on the product side, then it is reacting and you can get rid of it. So an ionic equation example. So if we balance this equation, if you were to go through and balance this equation, the next, which is the first step, we'll do this one in class, but I want you to try to do this, in your notes. Use the solubility chart to determine the states of matter. So calcium chloride, is it aqueous or is it solid? Sodium phosphate, aqueous or is it solid? Calcium phosphate, aqueous or solid? And sodium chloride, is it aqueous or is it solid? So from there, once you determine if things are aqueous or if they're solids, if they are aqueous, you can break them up. So calcium would break up into Ca2+, chlorine would break up into Cl1-. So instead of writing CaCl2, I'd write Ca2+ plus Cl1-. I'm just going to break them apart. And then I look at, are any of these solids? Well, I know that sodium chloride is not. It is aqueous. It stays dissolved. But is this a solid? in water? Does this precipitate out? If it precipitates out, then I only have the calcium and the phosphate reacting. So calcium and phosphate would be part of my net ionic equation, whereas the sodium and the chlorine they're going to be there, but they're going to be spectator ions because they're not actually participating in the reaction. So you're going to see some examples on the next couple of slides, and I want you to try to write the equation for this in your notes, and we will go through this one together. So there's a video clip here that you can watch now or you can watch in class. We will go through parts of it in class, but it does take you through how to do a net ionic equation. We are going to work practice problems in class, and you will have a homework assignment in class where you're going to write different types of reactions. So right here, this one gives you some examples to go through and do. So writing the complete ionic equation and then the net, the complete and then the net. This slide right here shows you how to do it. So I'm breaking apart the lithium and the chlorine, breaking apart the sodium and the nitrate, and or the silver and the nitrate, and you can see that they're broke apart. If things say aqueous, that means they dissolve in water. If things are solid, that means that it precipitates out. So this will react, but the only things that are really reacting are the silver and the chlorine. The lithium nitrate on the other side stays aqueous. So that's why lithium stays broken apart into lithium. And so that's why we cross that out. The chlorine goes from being bonded to lithium or being a free ion to being in this solid. So that's why I'm not going to cross it out. Same thing with the silver. But the NO3, it goes over here and it stays dissociated. So that's what we mean by complete ionic equation versus a net ionic equation. And you'll see the net just has the silver plus the chlorine giving me silver chloride. So really, this is the balanced equation. This is the complete ionic equation, and this is the net ionic equation. This is really what's showing me what's happening. The rest of the stuff is just there as spectators. So you can go through the second one too and compare how you did to this slide, because these are the same ones that are just written out for you. And we're going to do some more practice problems in class. We're going to do these practice problems in class plus the practice problem on the previous couple of slides. So you hopefully by the end of class today will have a pretty firm grasp on how to write the complete versus the net ionic equation. So the summary for objective number 4 is a 3-2-1 format, and we'll do that in class as well.